Welcome. In this video, we are going to discuss about ideal voltage and current sources. In order to make any appliance to work properly, we have to supply a proper voltage and a current. Only then our appliance will work properly. So, the operation of any appliance, the characteristics of the current and voltage source or the supply which you are using to make it to work is of utmost importance. Every load needs a source to drive it. The load may be driven by a voltage source or by a current source. A voltage source supplies a constant voltage to the load, while a current source supplies a constant current to it. The ideal voltage source is that voltage source or generator whose output remains absolutely constant, whatever is the change in the load. It possesses zero internal resistance. The internal resistance is inherent in the source due to its various components used in it internally. The voltage source is symbolically represented by a battery V and a series resistance Rs, where Rs is the internal resistance. The internal resistance of a voltage source always comes in series with it. In reality, there is no such constant voltage source. The voltage source, since every source has an inherent internal resistance Rs. In practice, it is found that as the load current increases or the load resistance decreases, the load voltage decreases. We can plot a graph of VL versus IL as shown in this graph. So we find that as the load current increases, the load voltage has to remain constant in the ideal case, but it is found that it is decreasing. Consider a voltage source V of internal resistance Rs in series with it as shown in the figure. It drives a load RL and produces a current IL through it. So if you look at this figure, we can see that this is the voltage source battery V whose internal resistance is Rs and it is driving the load RL. Now what is this load? This load is any appliance that we are going to use. For example, if it is a fan, then the load is the fan. RL, we represent any load by the resistance RL for ease of analyzing the circuit. Now because this is a series circuit, we can use Kirchhoff's voltage law to analyze this circuit. By KVL, the total voltage V supplied by the battery is equal to Vs, that is plus VL, or VL, the load voltage, is V minus Vs. Thus, we can see that VL is always less than V. Since Vs is IL into Rs, as IL increases, Vs increases and VL decreases. So, the load current drives the load. So, it can't be made equal to 0. You can see in this equation that Vs is the loss which is taking place in the circuit because of the internal resistance of this voltage source. So, we can make Vs equal to 0 if either IL equal to 0 or Rs equal to 0. But since IL is the load current, it is required for making the load to work, so it can't be 0. But we can design a voltage source such that it has a small internal resistance. Smaller the internal resistance, better is the voltage source. For critically designed voltage sources, a well-designed voltage source has a very small internal resistance approaching 0, often it is less than 1 ohm. So for ideality, the internal resistance has to be 0, which was stated in the beginning. Then if internal resistance is equal to 0, then Vs equal to IL into Rs is 0, so VL equal to V. That is, the voltage source characteristics approach ideality if Rs is much less than RL. Now let us analyze the ideal current source. The ideal current source is that source or generator whose output current remains absolutely constant irrespective of the load. It possesses infinite internal resistance. As before, the internal resistance is the inherent resistance of the source due to the various components used in it internally. The symbol of the internal resistance of the ideal current source is shown here. The arrow shows the direction of the current. it is having the internal resistance of the current source comes in shunt with the current source. So this is the way we depict a current source. In reality, there is no such current source, constant current source, since every source has a finite inherent internal resistance Rs. It is found that as the load voltage increases or the load current resistance increases, the load current decreases. The same thing can be depicted in the form of a graph as before. We expect that as the load voltage increase, whatever be the load voltage, the load current has to be constant as shown in the ideal case, but in practice we find that the load voltage decreases, load current decreases as load voltage increases. The reason for this decrease is the internal resistance of the current source. Consider a current source I of internal resistance Rs in parallel with it as shown in the figure. It drives the load RL and produces a current IL through it. So we can see in this circuit the current source I has the internal resistance in parallel Rs, and then it drives the load RL like this. So in this we can see that the load voltage VL and the load current IL supply the power required for driving the load. As before, the load is any appliance that you have to you want to run using this current source. The current IS is the current which is flowing through the internal resistance of the battery. Because this is a parallel circuit, we can use the Kirchhoff's current law. By Kirchhoff's current law, I equals IS plus IL, or the load current IL equal to I minus IS. Thus, IL is always less than I. Since IS is VL by RS, as VL increases, IS decreases and IL also decreases. So if we want to reduce this effect of the internal resistance, the loss in the power due to the current IS which is flowing, IS is VL by RS. So we can either make VL equal to 0 or we can make RS equal to infinity. We cannot make VL equal to 0 because it is required to run your load. So we can make RS equal to infinity, or we can make it as large as possible. So a very well designed current source will have a large internal resistance. Larger the internal resistance, better is the current source. For ideality, the internal resistance has to be infinite, which was stated already. Then, if internal resistance Rs is infinity, then Is equal to VL by Rs is 0, so IL equal to I. That is, the current source characteristics approach ideality if Rs is much greater than RL. Mostly, electrical sources or supplies such as the AC mains, cells or batteries are best depicted as voltage sources. That is, they supply a constant voltage to the load within current capability of the source. A well-designed voltage source would have a very small, non-zero, often less than 1 ohm internal resistance. Conversely, a well-designed current source has a very high but finite internal resistance, often greater than a few mega ohms. Now, if we want to select a voltage source for a particular load, we have to make sure that the internal resistance Rs of the source is much smaller than the load resistance RL. Similarly, to select a current source for a particular load, we have to make sure that the internal resistance Rs is much larger than the load resistance RL. That is, the source characteristics approach ideality if Rs is much greater than RL for a current source and if Rs is much lesser than RL for a voltage source. Thank you.